So simply put, inheritance is a way to create a class from another class or object that already exists. And at times, inheritance can reduce the complexity of the programming a lot by hiding some of the details or abstracting some of the details out. But at the same time, inheritance could also, if your inheritance tree is too deep, it could be a nightmare to follow and create and maintain the program. So there's a fine balance, especially when you're using inheritance, at least in my point of view, that you should be mindful of when you're using these inheritance techniques and creating objects from another object that already exists, right? So in essence, inheritance also allows you to share objects or share methods and attributes that are common across multiple classes. Instead of, well, you could always copy and paste the methods or objects or methods or attributes from one class or one object to another, but where's the fun in that, right? And again, the duplicate code means that equal amount of headache in terms of modifying one piece. You may have to go to 10 other classes to modify it, and maintenance could be an issue in that case as well. So again, there's a fine balance of using inheritance, how deep you use those, and quite often it's only 1 or 2 level deep that I've seen examples. So let's take a look at our car example that we did earlier, and see if we can build upon that to and take advantage of inheritance, right? So in our car example, that was just one type of vehicle, right? Now, what about if you wanted to use trucks and motorcycles and different type of vehicles and create a class object for each one of those? Well, there are certain aspects of all these vehicles that you can abstract them out, or you can share them. They're common across all of them that you can share, right? Such as mileage on these. Color is another one that I can think off the top of my head. Make and model obviously are something that's common across all types of vehicles. So let's see if we can put this thing together. Actually, I've already done the work just to save time in terms of typing and showing you the work. So I'm going to switch over to Atom here, and so we already had this class called cars that we worked on earlier. I've actually deleted all of that work and restarted from scratch. So what I did is created this a class or an object called vehicle. Now in inheritance terms of view, this is kind of called a base class, so something that everything else works off of, right? So in our base class, we have our similar we have our init function. In this case, this init function doesn't take in any parameters, right? And I'll show you how to make these work. And actually, there's a reason why I chose not to accept any parameters, because I wanted to show you the example of setter and getter functions that we talked about earlier in another video. So we've defined our constructor for a vehicle class. It contains about 6 attributes. They are all initialized in our constructor here, and then we're using set and get methods, which is, if you're familiar with C or Java, especially Java actually, you come across these setter and getter functions all the time. So our setter functions essentially set a value to the attribute, right? And notice that in this case, I'm using a single letter variable v instead of using miles or make or model as my attributes like we did previously. And that's simply because I'm using these function names to define what the work is being done here, as opposed to using the variable names. So we're saying set miles, always passing the self attribute. In terms of Java, these are passed in automatically behind the scene. In case of Python, we have to explicitly set them up. And again, note that the fact that this variable is called self, or the attribute called self, is more of a choice by design than the requirement. So you can name this anything. You can name this actually the word this, or any other variable name you like. It just makes it easier for everyone to understand if you use self. So we pass in a variable or one attribute, and then we set the attribute of miles to be whatever the value is passed in. And this is also where you could have a little bit of stricter control in terms of data type. So if you wanted only miles in numbers or numerical value, or like in integers, you can provide some stricter control over here. And then the same thing goes for make, model, horsepower, and the engine type and the base value, right? So these are some of the basic things that I thought of that every vehicle would have, and I set these attributes up. And then we also have get attributes. So these simply return the value of that variable. So I've also kind of abandoned the fact that of using the Perl version, Perl way of doing things, which was previously I said def c.make or card.make it was, and we passed in self, and then it was make provide with a default value of none, and then based on what the value of none or value of make variable is, we decided whether we were setting or returning the function. Instead, now I've explicitly set the set and get methods. And this convention of naming convention of these functions also come from Java, where you set the for all setter functions, it starts with the keyword of set, and all the getter methods start with the keyword of get. So I'm kind of following along those lines. Right, so these are setter and getter methods. Again, you don't have to create these. I just like to keep them this way, so it's a lot cleaner, especially when you're initiating an object. You don't have to pass along a whole bunch of attributes. You simply call the object and then set the attributes that you require one at a time explicitly, as opposed to, and your defaults are always set in your constructor. Right, so these are your setter and getter functions, and then you have additional parameters or additional prototypes of functions that you can pass along, right? So you can say type of a vehicle. In terms of the vehicle itself, this could be different for a car, for an SUV, a crossover, a motorcycle. So I haven't defined the details here. So just a simple example of a prototyping a definition or prototyping a function, where we define the function. If you wanted to pass in expect any attributes, you can pass those along, and the body doesn't do anything except for saying pass. Now this is kind of required that I write pass or some sort of a statement. If just by saying def function type, it will complain saying that's the body of the function is empty. So any other prototyping that you need to do, or any specific other functions that you could think of, you can add it to your base class, which then gets derived. All other classes will derive or use the base class to expand on. Right, so that's our vehicle class, and then I rewrote the car class from our previous example, and this time we are now using the inheritance or deriving our class car from the base class vehicle. So how do we use the inheritance feature? Well, one, we start with saying, well, first you have to import. You'll have to import your base class, right? So I've said from vehicle import everything. I could just say import vehicle, but then I have to say vehicle.vehicle here, or I'd say import vehicle as vehicle. But this just is a lot cleaner way of doing this. And also it kind of gives me control over which methods that I want to import within or inherit within this class called cars. So if there were only specific methods I wanted to import, I can pass in those specific methods, or just say star for everything that's in my base class. Right, some docstring, don't forget those. Don't forget the docstring for your individual functions as well, or individual definitions. Right then, so so the class car now actually inherits all the attributes, all the classes, all the attributes and all the methods that are defined in the vehicle, which means that those attributes and vehicles are available within the car as if they were defined and set within the car class. And I'll show you what I mean by that when we use the class car in our main program. So now that we have inherited, if you inherit a method or an object, you can use something called this overriding a operation. So I'm going to show you that in just a second as well. So, for now, let's just define our constructor for the class cars. So for this object car, we have a constructor just like we did previously, pass in self, and then this time around I am expecting or accepting 3 attributes for them, right? And now at the same time I'm inheriting, or since I've inherited the base class vehicle, I can actually initiate vehicle.init or force the creation or force the constructor to be called, right? So I'm going to call that constructor here, and when this is called, essentially we are defining the base types, or defining the default values for all these attributes. And then notice that I don't have set, make, model, and miles in here, right? In this class called car. So these are actually written in the vehicle module or vehicle class by using the inheritance. Since these methods are now available and used as if they were local to the car class, now I can actually call them, right? So I can say set make and pass in whatever the make value was passed by the user, the model and the miles, and set those up. Then within the class called car, I can actually create my own custom methods that are not available in vehicle, right? So now you can imagine the example of our company directory, where we have a personnel class which has first name, last name, and other demographic info. Now for each department you could have different methods and attributes that you wanted to use, right? The common stuff is make, model, and miles, or in this case, or first name, last name, and address in the case of a company directory. And then you can, based on what department they work in, you can have different methods. In this case, we have different methods for our car. So we have our sales sale price of car, and then we have a vehicle type defined as well. So now this variable, this function here, vehicle type, is actually exactly the same as the one that's in our vehicle base class. So this is what is called prototype overwriting or overloading these functions. As long as you write the function with the exact same name and exact same parameters being expected or accepted as what your prototype is or what was in your base class, you actually overwrite that particular function. So now whenever I call vehicle type, we use the default vehicle type, or we use the local function vehicle type in our car's object as opposed to the one in vehicle itself. Right, so that's our car, and I've also created another one called trucks. Again, same thing, we inherit from the truck or inherit from the vehicle. We're establishing our init function, and in this case I just wanted to show you that you could use both the set or you could use both the get value or the self.make as if you were writing it within this class called truck. You can say self.make and make value as opposed to using the set function. Also note that I have a new attribute called max capacity, which is defined here. Now this is not available in vehicle, in the vehicle class itself, so you can add on any additional information you need specific for this particular object. Right, so we've done that. Then we have a set and get method for this max capacity, and now we have a vehicle type here as well. So notice that this vehicle type has a little bit of different function body as opposed to what was in the car or what's in the vehicle class itself. So this kind of, you're overwriting, and then you can write specific logic for that particular object that you need to. You don't have to follow along with the same function type or the same information that you have for other classes. All right, so hope that makes sense, that you have a base class which kind of abstracts out all the basic or all the common methods that you may want to use for all type of in this case vehicles, and then we're now writing some specific values such as sale price or specific methods for our car object and attributes such as max capacity for our truck object. And then we can also overwrite or overload the methods for each one, as long as we follow the same name and the input parameters. All right, so how do we use this now, right? So in order to use cars and trucks, we can actually simply call them just like we did before. So I'm going to follow the from convention here again as well. So I'm going to say from car import star. So I'm going to import everything, and I'm going to do the same for truck as well. Right? Import star. So now I've imported my car and truck object, and let's initiate this. So I'm going to say my car is equal to car, and it takes 3 objects or 3 attributes: make, model, and miles. So let's pass that along. Here's our make, here's our model, and here's our mileage. Right, so let's call this 1,000. Let's make this 1,000 like that. Okay, so we have our object car, and now if I say print my car dot, now since car inherits the base class vehicle, I could simply say car dot get horsepower or get model, and that will provide me with the information that I need, that we set here in our class constructor or the car constructor. So if I say car dot get horsepower, right, or actually I should say get miles, now I should be able to this would return me 1,000, right? And let's run this. Sure enough, the miles are 1,000. So now if I run car, if I say print my car dot vehicle type, right? And now this is just a static value which returns car, which was defined here as vehicle type. So notice that the vehicle type was a bit different in truck as opposed to it is in car. Let's do one more for car, which is going to say sale price, which is a method that was specifically designed and implemented in the car class itself, right? So if I say print my underscore car dot sale price, if I run that based on our logic in here, if the miles are less than 10,000, the return price is 2,500 or 25,000, and that's what we get. All right, so cool. Now check this out. I can update some of this information. I can say my car dot set model. So notice that set model method is actually not in car, right? It's nowhere here to be found, but because we are inheriting from our base class, we are not allowed to use, and we're inheriting all of the methods that are from our base class. We can use the methods that are defined in our base class, right? So we can say set model, and I'm going to overwrite this to say RS4, or actually I should say RS6. And then if I run print my car dot get model here, I'm going to actually print this twice just so you know that it printed. model before update, right? And model after update. All right, if we run this, the model before update was S4, which is set up here when we initiated our car object. And then we can now use the set methods to modify any attributes that you need to, or set any attributes that you want to. And then we can print them using the get model. So pretty cool, huh? Let's work a same example with our truck. So if I say my underscore truck equals truck, and I think truck only expects 2 attributes, make and model. Let's call this Acura and MDX. All right, so now we have initiated our instance for truck. Now I can say my underscore truck. Actually, check this out. I'm going to say truck.vehicle type. I'm going to print this, right? And say truck type is. If you run this, it says crossover. Well, why is that? Because the vehicle type attribute or method is based on whatever the max capacity is. So by default, when we initiated the truck object, the max capacity is set to 5. So if I print this, we'll say 5. So print my truck dot get max capacity, and if I run that, it should give me 5. Sure enough, it is, right? So, well, MDX is not a crossover, it's an actual SUV. So how about we update that information first? So let's use my truck dot set max capacity, and we're going to pass in a value of 7. You can fit 7 passengers, and if I run this now, well, the truck type is SUV, right? If you go back here, and so now based on my capacity, which is set to 7, now we get a returned SUV. So I hope that makes sense. We don't have a sale price function that is in the truck as of yet, right? And we only have everything that is part of vehicle and whatever else is additionally written here. So you could actually inherit more than one class within, or you can inherit from more than one class, right? So, and to do that, you simply have to import that particular class that you want to inherit from. So import from car, import star, and then now I can say truck is it has 2 different base classes. One is, or 2 different base objects. One is vehicle and another one is car. So now I should have everything that's in vehicle and everything that's in car. So at this point in time, if I save this, it will still work. And in fact, I can say print truck sale price is, and I can say my underscore truck dot sale price. Right? So although we have not written sale price within the truck, but we are actually now borrowing from the car method, because we inherited car method as well. So it will go through this logic and print out the value for us. However, we haven't set any miles yet, right? So this init function goes to vehicle, and it sets up here that the miles are set to 0. So this should still work. It just won't give us something that makes sense. So let's say print truck's current mileage is my truck dot get miles, right? If I print all of this, now currently the miles are set to 0 because it's the default value, so it sets the current price. So what if I set the mileage for this truck? ERUCK dot set miles, and let's say 10,000, right? We set the miles for the truck, and then we get them, so it's set to 10,000, and the sale price is 10,000. That's because based on the mileage set here. Now, one cool thing to note here is that car actually imports from vehicle, right? So our our base class is vehicle, which then imports car, and now we're saying truck also imports car and vehicle. So actually I could remove vehicle altogether from the truck import inheritance class and just say car. So truck imports car, and car itself imports vehicle. So now truck should have everything that car has, which has everything that vehicle has, and then continue on forward, right? So just so you know that this will also work, simply for the fact that the inheritance, you can follow the tree along all the way up top to the base level. In order for this to work, I just have to simply modify this part to car. Actually, I don't even have to do that. I can simply overwrite the init function to say init this, and these are all everything that's left over, and everything will still work just the way it was. All right, so that's inheritance. Next up, let's take a case study of our FASTQ file parsing, and we're going to create a actual data object called FASTQ, and then we'll pass in create some of our own methods to take advantage of everything that we have for FASTQ, or everything that we know that we may need if you want to ever parse a FASTQ file.